Hello, this is our project, the design of a computer chip liquid cooling system for AI computing facilities. My name is Jose Cifuentes, and my group included Alexis Erwin, Adriana Rodriguez, and Garrett Tucker. Now, first, a little bit of background on the project. What is AI? Put simply, it is the attempt to simulate human intelligence in machines. Here, we specifically refer to AI computing in computers where they solve very complex problems. Now, what are AI computing facilities? It's quite simple. AI computing facilities are essentially data centers that hold hundreds of computers required for AI to perform the required computations. As they get bigger, as well as more advanced, more energy is required to run them and more heat is produced. Now, how do we handle this continuous increase of heat output? There are many ways to combat this, between raising the floor levels as well as the floor arrangements for improved airflow. You can also change the cooling mechanisms along the heat producing parts of the computer, including air versus liquid cooling. But for our goal in this project, we decided to evaluate what the optimal chip layout would be for our design in liquid cooling, deciding between pin fins and straight fins, as well as comparing the use of two types of dielectric fluid for both. Now, the research design and our results. Our initial research began with our professor. He had initially sent out an article that introduced us to design guidelines for immersion cooled IT equipment. There, we first learned about what dielectric fluids were, as well as what immersion cooling systems were. We learned about the difference between single versus two-stage immersion cooling systems. Those determine whether the coolant is liquid the whole time or if it's ever a gas in its entire cooling cycle. For our own research, we later on searched more into the dielectric fluids themselves, the immersion cooling types again as well. But we also searched for what the heat producing parts were in a computer system and decided on focusing on a single computer chip and the flow over that. Now, some of our design decisions that we made, like we said, we decided to focus on two dielectric fluids. We decided on Dowsel ICL 1000 fluid and 3M Novec 649 engineered fluid, types of mineral oil. Now, what we found in pure heat transfer calculations, the Dowsel fluid had a 185% increase of heat transfer compared to the mineral oil. And when we applied it to the straight fin configuration, it only had a 0.02% increase. However, when we include other factors such as price, the mineral oil is considerably cheaper, but another factor that you have to include when it comes to coolants like this is that corrosion. The mineral oil also corrodes at a much higher rate than Dowsel. Now, in conclusion, we ended up deciding that straight fins were the better configuration um, because it produced a over twice as much heat transfer. And like I said, Dowsel is the superior method for in terms of the both types of dielectric fluid. Thank you.